All right. Okay, great. So everyone can hear me. It is a pleasure to be here. It's literally been my dream to visit India. I'm almost 40 years old, believe it or not. I'm 38, and I've never been here. So this has been a dream come true. The food's been amazing. Everything has exceeded my expectations, and I can't wait to spend the next couple of days continuing being here. So yeah, thanks to the organizers. Thanks to everyone that showed up here. This conference is really great so far. We're just kicking it off, but I'm really impressed by everything. So. Really, the main point of the talk that I'm going to be giving today, though, is kind of a combination between React and GraphQL. It's a React conference, but I think what I'm going to kind of demonstrate today is that a lot of the front-end development and things that we consider front-end development are kind of merging to the back end, and we're seeing kind of this more cohesiveness between managed services and front-end developers. And that's really the focus of my talk, is kind of outlining those things. Everything I'm talking about today is going to be using AWS services because that's really what I specialize in. I work with AWS, but the actual implementation can be done in any of these ways. Just the general idea is using React with some type of managed GraphQL system. So you could do this with AppSync, but you could also do this with Hasura, Prisma, GraphCMS, 8base is really nice. Any other of these managed GraphQL services would kind of go along with everything that I'm going to be talking about today. And there's two main points that I want to really outline in this talk. The first is around developer velocity. I think one of the main differences between a lot of what you're seeing as far as companies being successful in the world today is the ability to develop and build things quickly, test things out quickly, fail quickly, and fail without having a lot of repercussions. So that really comes down to developer velocity, in my opinion, being able to build really quickly and being able to kind of get up and running and try things out without a lot of negative consequences, I guess you could say. And then the other is really around this idea of GraphQL as an API gateway. When you think of GraphQL, a lot of people automatically think of connecting to a database, but in reality, a lot of people are actually using GraphQL as more as like an interface to microservices, an interface to other HTTP endpoints, an interface to their database as well. But it's actually starting to spread out and become, much more of a I guess, an interface to everything in your application, not just your data source. So when you think of a common GraphQL flow, you have three main types, or three main pieces, I guess you'd say. You have your schema, that's your types and your operations. You have your data source, and then you have your resolvers. But at the end of the day, this is kind of a very common scenario where you see the database as the connection to the resolvers. But at the end of the day, resolvers are just functions. So anything that can be done in a function can essentially be done in a resolver. Think about Lambda functions. Think about sending a request to another HTTP endpoint, another microservice. So the point of this talk is abusing these resolvers. So thank you for having me. Welcome to Curious Cases of GraphQL. My name is Nader Dabit. I work with AWS, and I am Dabit 3 on GitHub, Medium, Twitter, and Dev.to. So if you're not already following me, please follow me. And I am a web and mobile developer. I've been a developer for about 8 years now. And I'm an author. I've written React Native in Action by Manning Publications. And then my newest book, Full Stack Serverless, from O'Reilly Publications. So if you're interested in the stuff that I'm going over today, this is, in my opinion, the most bleeding edge layout of technology in the serverless space today. We're actually kind of like breaking some ground on some new ideas and stuff in this book. And it's not just me, a lot of people are helping me out. A lot of people within AWS are kind of helping me get up and running with some of the topics that we're kind of going over in this book. And the last thing about me before I get to my talk is that I'm a futurist. And if you ask Yanni, this is his favorite thing about me. And I think being a futurist is a really, when I say Yanni, I mean Yanni Evakalio. I don't know where he's sitting. Is Yanni here? No, he didn't show up for my talk. I don't blame him. So basically the idea is being a futurist isn't really about predicting the future. It's actually more about being aware of the present. It's more about listening and observing what's going on and taking actions based on those things. And I think it's very, very intertwined with being an engineer, really being successful in any field where you're looking future forward, because you want to be able to focus on the things that are going to be big either like tomorrow, next week, next month, next year, 5 years from now, because you want to be able to ride the wave as it's cresting. You don't want to start learning something and becoming a specialist at something as the demand for that thing goes down. I think it's really been a really successful thing for me in my career to focus on things as they're kind of getting up and running, and being able to spot the things that are going to be very, very big in the future is a really big part of what's made my career successful as it's been so far. So the team that I work on is the AWS Client Technologies team. The two things that we focus on are Amplify and AppSync. I'm going to go over a quick overview of these, and we're going to kind of do a demo, and then we're going to go into some live demos of some actual applications that we've built and how we built those. For people that are not aware of AppSync, AppSync is a managed GraphQL service. It has all these different features. You could think of it as something like Firebase, but for GraphQL. And then Amplify Framework is the other thing that I work with. It's a CLI, it's a client, it's a way to kind of build cloud services and then connect those to your mobile application, your web application, to any application really. We have a thing that we're going to really dive into in my demo. It's called the GraphQL Transform Library, and it allows you as a front-end developer to kind of decorate a GraphQL schema with directives that will deploy back-end services using kind of your JavaScript and your front-end skill set. So to kind of get started on my topic and the demo I'm going to be going over, we're going to talk about the GraphQL Transform Library, which is part of the Amplify framework. And essentially all this is a set of directives that you can decorate your GraphQL schema with. And these are the directives that we kind of have so far. I'm going to go over model, auth, and connection because those are going to be the ones that I'm using. So with model, you can take a base GraphQL schema with a single type. Think of a to-do app, for example. A to-do app might need an ID for each to-do. It might need a title for each to-do, and then you might need to have a completed Boolean to kind of say whether or not that to-do is completed. But when you think about this schema, when you actually want to build an application out, what do you typically need for a real application? You need a database, you need an API endpoint, you need operations, so create, read, update, delete, and maybe even list. And then if you're using GraphQL, you might as well throw in some subscriptions in there as well because you want to have some real-time stuff going on. So in the GraphQL world, that typically means modeling out the rest of your schema with different mutations and subscriptions and queries. You also need to spin up a database, write the resolvers that interact between those operations in the database. What this @model directive does, it allows you to take a base type, add this directive, and then we build out the rest of your schema. We build out all of the resolvers, and we build out the database for you. And this is spun up in AWS, so it's a managed serverless resource. And then from there, you can kind of modify your GraphQL resolvers to match your business logic. The other directive I'm going to go over is the connection. And the other thing that is difficult for people when they're getting into GraphQL is how to model relationships. Using @connection, you can model one-to-many and soon, within the next week or two, many-to-many relationships between types. So you can take a talk that has comments, and that's going to be the schema that we're going over, kind of a conference API, and you can model a relationship between a talk and a comment. So when someone creates a comment, it goes onto that talk. You can then make subscriptions and listen to new comments coming from that talk, or just list the comments for a single talk. And then the last thing we're going to go over is the auth directive, and this allows you to model authentication and authorization rules around your different operations and your different types. So the two main types of authorization that you typically see are fine-grained access control, owner permissions, and then group permissions. So for a group permission, you might want someone that is an admin or a teacher or a student to have separate permissions than other people. And then for an owner permission, you might want to have only the person that created an item to either be able to read, update, or delete it, or you might want to have maybe an owner only be able to update or delete and then have everyone be able to read. So you might have no rules around reading. So those are the three directives, and the challenge that I want to have before I get into the actual projects that I've built with this is how can we build a conference API in 5 minutes? We want to build not only the schema, but we actually want to really deploy the database. We want to deploy all of the resolvers. We want to model out the entire schema, and we want to apply authorization rules as well to that. And we also want to kind of have a way to test this locally. I don't know if you've ever built something like this that's actually production ready and scalable, but typically building something like this from scratch can take not hours, but days, weeks. I mean, who knows, right? Because when you're thinking about authorization rules, you want to make sure everything is working right. The challenge that I have is, can we build this in 5 minutes using this GraphQL directives? And that's what we're going to do now. So I'm going to jump to my first demo. And during this talk, I want to challenge you to send a text message to +1 910 249 6765. If you can't remember that phone number, you can go to smschat.dev. I'm going to walk through how this is built in just a second, but it's actually built using GraphQL as well. So for the demo, what I want to do is I'm going to be starting in a example React. I'm kind of more in like a base project that's just an Amplify project. And what I want to do is I want to go ahead and add that API. So I'm going to run amplify add API. And we're going to build a conference API. So you can either build a GraphQL or REST API. REST API would be Lambda Function. GraphQL is AppSync. You can give the API a name. You can choose the authorization type. So OpenID Connect allows you to bring Okta or Auth0 or whatever. API key just means you send the API key in the header. And then Cognito is a managed authentication service similar to Auth0. And I already have that set up by running amplify add API. So I'm going to amplify add auth. So I'm going to use that. And I think my text is a little bigger than I thought it was going to be. So I'm going to reduce the font size just a little bit here and see if this is a little better. Makes it a little more readable. It's still kind of big. It doesn't seem to be changing, does it? Okay, well, I guess we'll just deal with it for now. So anyway, so we're walking through the next step where we chose the authorization type. Next we're gonna choose if we want to configure some advanced settings. I'm gonna say no, we don't. Next, it's asking us if we have a GraphQL schema that we'd like to use already. If we did, we can just reference the path of that. If not, it'll prompt us with the option to get a few different boilerplates, GraphQL boilerplates that we can start with. One of the boilerplates is a single object with fields, which is a to-do app. The other is a blog, which has a blog with comments. A blog with posts and a post with comments. And then the other is something with fine-grained access control. But we're going to be starting from scratch. So I'm going to select single object with fields, and we're going to kind of take this base, and we're going to be completely stripping it apart and rewriting it from scratch. So the first thing I want to do is I want to go ahead and create a talk type. The talk type is going to be the base of our API, where we have a talk name, a talk summary, a speaker name, and a speaker bio. And I've decorated the type with the @model directive. This will build out the database. It'll build out the resolvers and the rest of the schema. The next thing I want to do is I want to add a comment type, because we want to be able to have a talk, and then in the app we want to have people be able to comment on the talks, and we also want to have subscriptions, and using that model we'll have the subscriptions as well. The next thing we want to do is we want to create a relationship between the talk and the comments. So to do that, we can actually add a comments field to the talk, and then just say we want an array of comments to populate this comments. And to create the relationship, we can just add the @connection, and the @connection just needs to also correspond to the other type that you want it to correspond with. So here we have a connection between talk and comments, and we give the name of the same name so we can kind of model that relationship. So now when we create a comment, we can reference the talk ID. The last thing we want to do is we want to add authorization rules. So for a talk type, maybe we only want admins to be able to create a talk, right? Because anyone logged into the app should not be able to change anything, but they should be able to read the talks. So we want everyone to be able to read, but only admins to be able to do any mutations. So to do that, we can set the rules to groups, pass in an array of groups that can either be hard-coded here, or they can come dynamically from one of your GraphQL fields. And then we set the authorization rules to null for queries, because for queries, we want to be able to allow anyone to read the talks, because basically we don't really care about the who can see the talks, right? And the last thing we want to do is we want to add some authorization rules around the comments. We want to only allow the person that created a comment to be able to delete or update it, but we want everyone to be able to read the comments in the app. So we set the rules to allow the owner. We set the owner field to correspond with a field that we already have. This way we will be populating that field and it'll be coming from the JWT, so we don't need to pass in anything, and it can't be kind of like faked. You can't fake your own identity. It's securely read from the JOT. And then finally we set queries to null because we don't care who reads the comments. We want those to be visible. So that's about it. We've built the app. What we can do now is test it. And typically testing things that are serverless are kind of hard, because when you test things that are serverless, you typically have to like either build something in the cloud, or you have to have a pretty sophisticated local testing environment. And that's what we've built. We've actually built a very simplified version of a local testing environment. So what I can now run is amplify mock. And this is going to mock our entire application locally, and it's not going to actually create anything in the cloud. What it's going to do, it's going to see the two @model directives, and it's now generating those two databases locally using a SQLite database. So now we see that we have the talk table created and the comment table. Next, it's going to prompt us for GraphQL code generation, because when we're interacting with the API locally, we need to have the definitions for queries, mutations, subscriptions. So we can choose either JavaScript, TypeScript, or Flow. I'm going to choose JavaScript. We can choose the location for the GraphQL code that's going to be generated. We can say whether or not we want everything to be created. And then finally, we can define our maximum statement depth. So now that we've defined all of that, we have our endpoint running at this local host. So I'm going to go ahead and pull this up. And what you'll see is we have a graphical editor built in. And what we can do now is create a new mutation. So the mutation I want to create is a new talk. I want to pass in a speaker bio, speaker name, talk name. So what is it? Curious cases of GraphQL. And then the talk summary, whatever. GraphQL is cool. So now we want to be able to go ahead and create this and test it out locally. I want to return the ID and all this other information. So we'll go ahead and press this. And you'll notice automatically that I am unauthorized because I am not an admin. So our authorization rules are working exactly as we expected. So let's go ahead and mock a admin by opening our groups, our auth options actually, and we can generate a new JWT. And I want to go ahead and simulate the username of Dabit3. So that's kind of what I go by. So I'm going to go ahead and generate a new JWT. And now when we simulate the operation, it actually is successful because it's reading the group's claim off of my identity in the JWT. So we've created a talk. Next, we want to go ahead and create a comment on the talk. So what I'm going to do now is go to create comments. I'm going to take this talk ID, and I'm going to pass that into the input as the comment talk ID. And then the message is going to be best talk ever in my life. All right, so we've done that. I'm going to now return. I'm going to return the ID and the message, but I'm also going to return created by because I'm not actually passing the created by in as an argument. If you notice, we're going to be reading that off of the JWT. The only thing that we're passing in is the ID of the talk and the message. So now I should be able to go ahead and create this my mutation too, and we get that information back. The next thing I want to do is I want to update the auth to be an attendee of the conference. And I'm going to remove the admin privileges. I'm going to go ahead and generate this JWT. So now I'm kind of signed in as a new user. And what I want to do now is I want to query all of the talks from the API. So I'm going to go add a new query. I'm going to say list talks. And I'll go ahead and delete these operations here to make this a little more readable. And what I want to return is the items array. And for every talk, I'm going to return all the metadata. But what you're going to notice is we now have a relationship in our editor for comments. So we can also return the comments, and we can return all of the information about all of the comments. So if I run this, we'll see that we get a return an array of items. The items have our talk information, and then they also have an array of comments. And there we'll have all that information. So now we have our entire functioning API, everything ready to roll. All we need to build out is the front end, and we're front end developers, so that's the easy part. So like the back end part is now taken care of for you. You run amplify push, it's published to the cloud. You have your local HTTP endpoint for your GraphQL API generated locally. You can then just interact with that using Apollo. You can use our own amplify, client, whatever you'd like. So that's kind of the demo as far as like what I use to build out the demos in my talk. So now let's like get into a few different actual use cases that we've done with this. The first one I wanted to show is this is a really interesting, I guess, to me, like thing, and it doesn't make a whole lot of sense, in general actually. But what if you had a way to send Markdown in a text message? What if you wanted to be able to say, hey, I want to send you like link with some code and maybe, whatever. I want to like send you a blog post I guess even in a text message. So how could you do that? Well, that's kind of what I've built. And I built this SMS chat.dev just to kind of see how we could do this, because I had a customer that I was working with that needed a way to do text messages into GraphQL to trigger a GraphQL mutation. Thought it was a cool way to kind of demonstrate that reference architecture. And what I basically did to build this is I used Amazon Pinpoint. And the Amazon Pinpoint allows you to kind of create phone numbers that send events to anything in a cloud architecture. So once I create the phone number, I chose to send those events to a Lambda function. The Lambda function then takes the information out of the event, which is the phone number and the message, and triggers a GraphQL mutation into AppSync, and then any client that's subscribed to that subscription will get that new updated data locally. So you end up just having the client subscribe to the application, and then any events coming through will be read to the client in real time. So how does the data look for this? Well, really all we need is the origination number, so we can have some type of information around who sent the message. And then we want to have the message body, which is going to tell you exactly what the user sent, and that's really about it. Nothing too complicated there. So to model this back end, we used a @model directive with an origination number, a message body, and ID. So pretty basic stuff. And for the Lambda function, this is kind of the interesting part to me. In the event of a Lambda function, you can pretty much read all the information that's been passed in as arguments. So in this example, we have a message that we pull off of the event records SNS message. And I think the event is going to be different for every type of thing that is sending the event to the Lambda function. So this event information is going to look differently to each application. So anyway, what we do is we parse that data. We then retrieve the origination number and the message body, and we just make a raw request to GraphQL using Axios. In this example, we pass in the API key, we pass in the variables, and that's about it. We then do this, and it triggers subscription on the client. So what we're going to do is we're going to try this out. And all right, we already have a few messages, but what I want to do is, Tanae has my phone, so I'm going to ask him to bring that to me. One of the highlights of my trip is actually meeting Tanae for the first time, by the way. I'm a big fan of Tanae, and I'm also a friend of Tanae. So what I'm going to do is test this out. And I'll send a message here in Markdown. And what I want to do is maybe test this out. There we go. Someone's sending some Markdown already. Maybe I'll send like a link. And if anyone wants to send some cool stuff, feel free to. But to demonstrate the Markdown functionality, I think a link is pretty cool. So I'm going to try to post maybe a link to the React India website. So just be patient with me for 1 second. And anyone that wants to participate, feel free. I guess I could have planned this out a little better, huh? To make this fast, I'm leaving off the HTTP. Oh, there's a link. Well, we'll try this out. Oh, there's React India. So, so you start seeing that we have Markdown coming in. Looks like my link doesn't work, but whatever. Anyway, let's try this one. I don't know, should I click on that link? God knows what they put there. Oh, YouTube. Let's see what YouTube video they linked this to. Oh, okay, nice. All right, that's good. Okay, anyway, let's go to our next demo. I got rickrolled on stage. What if you wanted to do something stupid like image recognition with GraphQL? And like, why would you want to do that? I don't know why you would want to do that, but I think building stuff like this is interesting because you learn how to do things that you might not even think about doing when you're building these types of things, because you learn something along the way, and in the future you might come up with a use case where this actually makes sense. But to do image recognition in GraphQL, this is what I ended up with. I think when you're working with images in general or videos in GraphQL, the one thing you need to understand, in my opinion, the best practice is not to send the raw data to your actual database. The best way is to actually upload the image or video to something like a content management system. I think Cloudinary or S3 is what I use, anything like that where it works great. Then you get a reference to that image and you store the reference in your GraphQL database. And that way you're actually just referencing the location of that image and you're not actually sending data back and forth over the network. You're actually getting that network location from some other content delivery network. Therefore, you can do things like caching and things like that. So what I end up doing is in the client, we first upload the image to S3. That gives us a URL for the location of that image. And then we send that location of the image in a Lambda function using GraphQL. And in that GraphQL request, we take out the location of that image, and the resolver is kind of how it gets there. We then use a managed AI service called Recognition, which allows you to do machine learning on images, and you can choose like from 30 or 40 different methods. The two methods that I'm going to show off today are label images and detect faces, so you can kind of get information about like people's faces in a picture pretty much. And then after the recognition data comes back, the return data from the operation gets sent back to the client, and you basically can use that to show it off in the client application. So to build this, the data was pretty simple. It's essentially just a URL that's an image location. So once we have that, we have two pieces of data in our schema. We have the image data, which is the data that's actually coming back from the recognition service, which is essentially a JSON object that's been stringified, and then we parse that on the client. And then the operation that we send to get this information can be either a query or a mutation, and we're passing in the URL, and then we have an optional type, because there's two different ways that we're going to show how to do recognition. One is with labels and one is with faces. So if we don't pass in a label, we automatically detect faces. If we do pass in the label, we'll detect labels. So what does the Lambda function look like in this case? Well, first of all, we check the event type, and if we have labels, we set the attributes to some information that has to do with labels. If not, we set the attributes to something that has to do with faces. We then create a params object with the bucket name for the location of the image and the name of the image, which is the event.imageinfo, which is the URL of the image. And then we have those attributes kind of spread out in that object. And then we check to see if the event type is a label or if not. And then we call two different methods, either detect labels or detect faces. This just allows you to upload the image and it returns JSON back with all the information. So for the demo, what we're going to do is pull up GraphQL Recognizer. And I think I'm going to need a volunteer for this one. So who wants to volunteer to come on stage with me? I have free swag for you if you do this. All right, come on, let's do it. So what we want to do, you can come up here. We want to go ahead and get in front of the camera, and we're going to go ahead and take a picture. So we're going to toggle the camera. All right, let's move these out of the way.
I think I'm photogenic.
Okay, oh, there we go. Okay, sorry. Yeah, I'm not good at this. All right, 1, 2, 3. All right, there we go. So let's wait a second and see what happens. What this is basically doing, it's taking the image data, storing it in S3, returning the location of that image, then running the image through a machine learning service and giving us that information, and then we display that in the UI. So we get here, number of people 2. One of us is 28, the other is 30. I'm 28, he's 30. We have some emotions. One of us is happy and angry, and the other one is disgusted.
There's something wrong.
There's a little. So both of us. One of us is smiling. One of us isn't. I think he's the one that's smiling anyway. Overall, like, we get this information. I think the one thing that I see for sure that isn't correct is glasses. I have my huge glasses on today, and it did not recognize that. So thank you for coming up here and being a good sport.
Thank you.
You can pass out those stickers. If anybody wants an Amplify sticker, I have some, and now he has some. The next thing I want to do, though, is let's upload an image that has a little more complex information in the image. So I'm going to upload our image last night from the speaker's dinner. So this was us in the hotel restaurant eating dinner with all the speakers last night. What I want to do is recognize people, because now we see that instead of just 2 people, we have like a bunch of people. So this is going to take a little longer because the image processing is going to actually go over this image and actually do different algorithms based on every single face in this picture. So we're going to see that there's, I don't know, 30 or 40 pictures here, and then hopefully we'll get an idea of the gender of the person, the beard, Yanni's beard is going to show up, and all these other things. And yeah, this might take a little longer, so I'm going to give this a second. And if this takes too long, I might just skip over it. So I am going to let this run and then continue on to my next demo. And then if I come back and it's finished, we'll take a look at it. So the next thing I want to demo is real-time music collaboration. And this demo came out of an actual real use case that I worked with a customer on that had a step sequencer that wasn't music related, but it was actually related to some other types of data in general, where we basically were stepping over information in a time series based way, and we were doing things based on the current step in that sequence. And what we were doing in that case was real time, and it was collaborative. So I wanted to kind of like do something with that use case, and this happened a while back, and I never really I thought it was just a really cool thing. And then I saw a few months later that Ken Wheeler from New York, one of my good friends, had built this thing called the Traplord 9000, and it was a step sequencer. It was literally the exact type of thing where I could actually use the ideas that I learned and actually build something fun with it. And a step sequencer to make beats essentially just steps over a bunch of different beats, and depending on whether the beat is selected or not, it plays that sound in that sequence. So I cloned the Traplord 9000 and I launched a website called hypebeats.dev that basically allows you to take a beatbox and collaborate with other people on it, and it's just a really fun demo. So how does the data look for something like this? Well, first of all, we have the data modeled out that is essentially a bunch of arrays for different types of sounds. So a kick, a sub, a snare, etc. If the value is set to 0, that means the sound does not play. If it's set to 1, it does play. If it's set to 2, then it does like to 2. If it's set to 2, it does like a triple beat. So we step over the sequence and we play the music. And how could we actually build this and make it work with GraphQL and make it real time? Well, first of all, I defined this schema that worked pretty well. And it's really, really basic. If you look at this, all we have is an ID and a client ID to define the different machines. The ID, of course, is just a unique identifier, but the client ID is an ID that defines the person that created the last operation, because we don't want to subscribe to things that we changed ourselves, because we're going to basically be doing an optimistic response locally. That way, when the new data comes down, we already have the most updated data, and we just discard the data that we changed. We have the beats stringified into a string, so we take that array, we stringify it, we send it to the database. When things change, we then parse it on the client and then update the UI using React set state, or update the state in some way. And then we have a name for the drum machine. So that's kind of it. Let's go ahead and demo this. Well, there we go. The information finally came back. So we have 31 people. Yeah, let's see if we have any. There we go, females. We do have a few in the crowd, which is good. And it did recognize that, so everything seems to be working. And then last thing I'm going to do, I'll just let this recognize labels run while we take the next example. So this is Hypebeats. You can check it out and kind of use this if you like. It's hypebeats.dev. And I'm going to go ahead and open a drum machine that I already kind of pulled up. And what I want to do is kind of just demonstrate how this actually works. So say, for example, I'm on this right drum machine, and this is someone else, somewhere else in the world. And they're creating like different, different things. And then I'm over here in India, and I want to go ahead and listen to the things that they're playing. The person can now make these beats over here, and then I can kind of listen. And if anyone wants to collaborate, they can jump in. Let's test out the bass in this place. Let's see if the bass actually works pretty good here. There we go. Someone jumped in. All right, so I don't have to do anything. Someone else is doing the work. This is the official soundtrack of React India. All right, I have to turn that off now. Sorry. Party is over. The next thing I want to look at is infrastructure as code. Now, infrastructure as code is something that you might not be too familiar with if you're a front-end developer that's never worked in cloud computing, but you might have heard of it. The problem with infrastructure as code, in my opinion, is that it's very complicated to get started with cloud computing in general, and then to use infrastructure as code, you basically have to have a very advanced understanding of building cloud resources. And to me, that's just too much work. I'm a lazy person. I like to build things as quickly and as easily as possible with the least amount of work, and I like things that scale. And I think that what we've come up with in the Amplify CLI is a really interesting use case around infrastructure as code. And I'm going to show you how we can use this to build a couple of interesting projects. And I'm going to talk about a pre-launch that I'm going to be launching soon, but this is kind of the first time I've actually talked about it publicly. So GraphQL infrastructure as code. This is in the wrong place. The way this came about, as far as like being a real-world scenario that actually worked in my experience, was I gave a talk at Chain React called hooking up a conference in real time or something like that. And it was about me helping build the conference app for the Chain React conference. And what we did was we took the 2018 version and we just kind of like cloned it and we added comments. And we wanted to do this, as cheaply and as quickly as possible because they have Infinite Red as who runs the conference, and they have a million things going on. And this was a good opportunity for me to kind of like use the GraphQL subscriptions with comments and kind of put this and use it in a real world example and talk about how I did it. So that's kind of how the conference app originally kind of started. And then after I gave that presentation, we used that app in the conference. It worked out really well. Everyone liked it a lot. I had a bunch of people actually come up to me and ask me, hey, how can we do this for our conference? This is really nice. We want to add this same functionality. And what I decided to do was, instead of like helping each individual person, I wanted to build a full stack application and open source it that people could actually use in their own event. And what I came up with was Conference App in a Box. And Conference App in a Box is a combination of this infrastructure as code and the entire React Native application. And it's themable and it's open source, so you can essentially just clone this app, change a few things in the configuration for the theme, and deploy it, and you can have all of this done in about 15 minutes. And if you go to the GitHub repo, it's Dabit3/Conference App in a Box. I have a link to YouTube where we actually walk through this, and we do it in like 20 minutes because we're kind of taking our time walking through describing things. And this is the old example. Now I'm going to kind of show a newer thing that I'm going to be launching today, or pre-launching. And so to build something like this, it's very similar to the schema that we looked at earlier, where we have a talk type and a comment type. And how do we actually build this infrastructure as code, and what is infrastructure as code? Well, infrastructure as code is essentially just code that, when deployed to a cloud, deploys services that you need to kind of have your entire application running. So for this example, you would need authentication, you would need a GraphQL API, you would need a database, and you would need resolvers and all of that stuff. So what you can do is either write this stuff from scratch yourself as infrastructure as code, or you can use the Amplify CLI, where we actually do all this stuff for you underneath the hood using a command line interface. It's much more, to me, easier because I'm so used to working with the CLI anyway. It allows us to kind of use our existing knowledge to kind of do this. So to build this new conference app in a box, I started off with a brand new API. I built the front end first. I built the React Native app first using data that was local, static, data. And then I built the API and replaced that local data. So Amplify init creates the new Amplify app. Amplify add API adds the API. Amplify add auth. I left that step out there, but you need that for authentication. Then Amplify push will kind of delete everything. Not delete everything, deploy everything. Anyway, what you end up with is this backend folder. And you have the API folder with all the different APIs. So this could be a bunch of HTTP APIs that you built with REST and Lambda functions and serverless, whatever. But you'll also have your GraphQL API here, and this is all we have for this conference app in a box. Here we have the schema. So we have our GraphQL schema, and then we also have our build, which is the final build of the actual app after we launch it. So let's kind of take a quick demo at the conference app in a box. I'm going to open up the simulator, and what we have here is an example of this app running. And really, there's not much to demo here except for, I think the cool thing about this is the comments. So there's Vladimir there, Powering VR. He's here at the conference. And let's make a comment on this talk here. So this is the real app. This is kind of how it looks. So it's not an ugly app. It's a nice looking app. And what we want to do is let's go ahead and simulate a comment in real time. So hopefully the WebSocket connection is still open there because I haven't closed my computer and done anything stupid. And what we're going to do is we're going to go ahead and query and list all of the talks in the app. So here I am in the graphical editor in the AWS dashboard. So I'm going to look for accessibility as a first-class citizen, and I need that talk ID to create a new comment. And what I want to put here is hello from India, and created by is me overriding the old, in this example, for the example, I want to be able to create comments from other people, so I kind of modified the schema that allows you to pass in the user. So what I want to do is create this comment, and the subscription does not seem to be working, so let me try to refresh this and try one more time. I think I jumped networks and something happened or something. Oh, no, okay, never mind, it's not that, it's something else. I just need to refresh the screen here. Okay, let's try that again. So I'll go ahead and create this comment. Oh, there we go, it's successful. So we see hello from India, and maybe I'll, and go ahead and do that. So we have another talk comment coming from Jennifer. So yeah, it's all working. So you can literally deploy this app and have it up and running in about 15 minutes. And the really coolest part about this is I've actually worked with 20 or 30 conferences at this point to either talk about using this or use it and use it for their next event. And I actually talked to a consultant that charged $15,000 to deploy this app for their client. And it took them just a couple of hours to deploy it, theme it, and it was ready to roll. So people are using this to make a lot of money. And this goes along with the idea of full stack serverless. I think that's kind of the future. And what I want to show now today is a project that I'm working on, and it's ready, but it still needs a little bit of polish, so I'm going to launch it next month. It's called Stack Cms. And Stack Cms is a full stack serverless end-to-end solution using Gatsby, and it's built for now on AWS, and we're going to make this extensible to also work with other providers as well. So we want to make this work with Netlify, we want to make it work with any CMS combination out there, but the first version is what I'm focusing on, is working with Amplify and Gatsby. And it's essentially, just a full stack CMS built with Gatsby and serverless technologies. So what are some of the features on V1 or V0.1? Whenever I launch this thing, this is what's going to be part of it. You have a full stack website in minutes that has two different types of pages that can be built. You can either build a website page or you can build a blog post. You have authentication and authorization with rules based on admins built in. So from the command line, you can run Jamstack configure to add admin emails before you deploy. Then when someone signs up with one of those admin emails, they're automatically added to the admin group, which gives them access to the admin panel where they can create, upload new images. They can reference the images that are available. They can create posts and pages, and then they can view the current version of the app in the admin panel, because when you're using Gatsby, you're actually using a server-rendered application. So you can basically get a preview of the application, and then when you're ready to deploy it, you can run the Jamstack deploy or Jamstack develop to develop locally and get an updated version of the static site. And then you can serve that from Netlify, you can serve that from the Amplify console, you can serve that from wherever. And the really beautiful part about this is that you're using signed images from S3 that only need to be downloaded once at build time because the images are actually downloaded locally to a downloads folder, and then they're served from the local application, which makes it performant, but it also makes it cheaper because you're not requesting your images from S3 every time someone views an image. It's just already available locally. But anyone in the world can actually work on the application. Your customers can work on it without having to know anything about JavaScript. Your JavaScript developers can use it and customize their theme. Real-time comments are built in. Free built-in, it's preview links. So preview links is really cool because you can generate a preview link with a click of a button, share that anywhere around the world, and get feedback on your server-rendered application before the build time. And it's completely CLI based. So if you want to learn more about Jamstack CMS, I have a Twitter account, and we have jamstackcms.io. That's not finished yet, but that's going to be the website. So if you want to learn more about Jamstack CMS, follow along and maybe get in on a beta preview, you can follow us at Jamstack CMS on Twitter. That's the end of my talk, really. So the idea is building things in a fashion that I like to call full stack serverless. It's a way to kind of use your front end skill set to build full stack and scalable applications using mainly JavaScript technologies. To do any of the applications that I'm going to show the code for, you clone the application, you run amplify init, amplify push, and you're ready to roll. All of the code for everything I just showed is on GitHub at Dabit3/Curious Cases of GraphQL. You can follow me again on Twitter, Dabit3, if you're not already. And then I took images off of Unsplash. So Jens Johnson, Kareem Mandra, Christian Spies, Edwin Andrade, and Hal Gatewood. I used their images in my presentation. And that's it. Thank you for having me.
Recording was brought to you by Twilio. We allow you to integrate different means of communication such as video, chat, or SMS into your React applications. If you want to learn how you can send SMS directly from a React chat, check out this video on the right or go to our Twilio YouTube channel. And if you want to watch another React India talk, we picked one out just for you over here on the left. Thanks for watching.